Hello and welcome to this video on proof by induction, this time on matrices. So we've been asked to prove by induction that that matrix there, 15, 28, negative 7, negative 13, all to the power of n, is given by 14n plus 1, 28n, negative 7n, 1 minus 14n for all positive integers. So as usual, we start with the base case when n equals 1. So when n equals 1, we substitute n equals 1, and of course the matrix just stays the same as it is, self to the power of 1. On the right hand side, when we substitute in 1, we get 15, 28, negative 7, negative 13 again. So as the left hand side and right hand side are the same, is therefore true for n equals 1. We then move on to the assumption where n equals k. So we're assuming it's true for n equals k, which means that we just replace the n's in the original statement with k's. We're then going to use that assumption in our inductive step, the next step. So for our inductive step, we are substituting n as k plus 1. So when we have the matrix to the power of k plus 1, that is the same, of course, as the matrix to the power of k multiplied by the matrix to the power of 1. So just multiplying by the matrix once again. But we've already made the assumption that the matrix to the power of k is 14k plus 1, 28k, negative 7k, 1 minus 14k. So then we do our matrix multiplication, which, as you should know, means timesing the top row elements of the first matrix by the first column elements of the second matrix, and so on, to produce a new 2 by 2 matrix. So I'm going to assume you understand the concept of matrix multiplication. And when we simplify all that, we get 14k plus 15, 28k plus 28, negative 7k take away 7, and negative 14k take away 13. Now, of course, what we're trying to do is show that the answer is the same as the matrix we're assuming, but with k plus 1s instead of k. So if we manipulate each of the elements in our answer, we can rewrite them in the form of something. So, for example, 14k plus 1 is the same as 14n plus 1, where n is k plus 1, etc. And we can do that for all 4 elements. Therefore, our answer is true when n equals k plus 1. So all that remains is for our conclusion, which is always the same. So since it's true for n equals 1, and since if it is true for n equals k, it's also true for n equals k plus 1, it is therefore true for all n. Thank you very much.